So the third example is x plus 2y minus 3z is equal to 1, 2x plus 5y minus 8z is equal to 4, 3x plus 8y minus 13z is equal to 7. This one is its corresponding augmented matrix. First of all, the pivot entry in the first row is 1. That's why we have eliminated the entries below the pivot entry. And for that purpose, we have utilized R2 minus 2 times R1 and R3 minus 3 times R1 also. So the first row will become same. Now 2 times of 1 gives us 2 and subtract that 2 from this 2, we will get 2 minus 2. 2 times of 2 gives us 4 and subtract that 4 from 5, we will get 5 minus 4. 2 times of minus 3 gives us minus 6, and due to subtraction that minus 6 will become plus 6. So we will get minus 8 plus 6. Now 2 times of 1 gives us 2 and subtract that 2 from 4, we will get 4 minus 2. Similarly, 3 times of 1 gives us 3 and subtract from 3, we will get 3 minus 3. 3 times of 2 gives us 6 and subtract that 6 from 8, we will get 8 minus 6. Similarly, 3 times of minus 3 gives us minus 9, and due to subtraction that minus 9 will become plus 9, and we will get minus 13 plus 9 here. Similarly, 3 times of 1 gives us 3 and subtract that 3 from 7, we will get 7 minus 3. Now just simplify this one, you will get this one. Now, since this one was the first pivot entry, now the second pivot entry is also 1. So we have to eliminate this entry 2. So for this purpose, we will subtract 2 times of second row from the third row. So that's why I wrote here R3 minus 2 times R2. This one is our desired operation. So just do apply this operation, you will get 1, 2 minus 3, 1, 0, 1 minus 2, 2, 0, 0, 0 and 0. So for the solution, we will use the rows of this matrix. So from third row we get 0 into x, 0 into y, 0 into z is equal to 0, get nothing. Now from the second row we obtained 0 into x plus y minus 2z is equal to 2. 0 into x plus, 0 into x plus y minus 2z is equal to 2. Shift this 2z on the right side, you will get y is equal to 2z plus 2. I wrote here y in terms of z because z is a free variable. What does it mean? Let's accept it here. Later on, in the end of this example, we will discuss it. From the first row, we get x plus 2y minus 3z is equal to 1. Substitute these values in this equation, you will get x equals minus z minus 1. So the value of x is minus z minus 1, the value of y is 2z plus 2, and z will remain same. This one is representing the solution of this given system. Now let's discuss this system in terms of rank, basic variable, free variable, and so on. Clearly, in this system, we have only 2 pivot entries, and shows that C1 and C2 are the pivot columns. So it means x and y are the basic variable. So since x and y are the basic variable, while what about the z? So the z will be a free variable. So that's why I wrote here z is equal to z. Since z is a free variable, so we take it z equals z. Since rank of this augmented matrix is 2, because number of non-zero rows is equal to 2 in this augmented matrix, and also the rank of this coefficient matrix is 2, so the ranks are same, that is 2. And in the given system we have 3 variables and the rank is 2. This shows that there is a free variable, and that free variable is the z variable. Since the system has a solution, so we write here the system is consistent. Is this solution a unique one? No, because if I take z equals 1, I will get, for z equals 1, we get xyz equals -1 -1, put this value of z, we will get -2, put 1, 2 plus 2, 4, and z will be 1. For z is equal to 0, xyz is equal to, if we put z 0, we will get -1, we will get 2 and 0. So this shows that for each value of z, you will get a solution, and hence here we have infinite number of solutions. Although the system is consistent, but we have infinite number of solutions. Now let's draw a chart to memorize this whole discussion easily. Now this is the chart of today's whole discussion. We discussed linear system, so a linear system may be consistent or inconsistent. If the rank of augmented matrix is greater than rank of coefficient matrix, then the system will be inconsistent. And in this case, we cannot proceed further. And already we have discussed an example related to this case. If the ranks become same, then the system will be consistent system. So in case of consistent system, we can obtain the two different types of solutions. Number first, unique solution and infinite number of solution. When all the variables become basic variables, then in that case you will get a unique solution, and when you obtain a free variable or free variables, you will get infinite number of solution, and in that case the solution will not be a unique one. And for the solution, you have to express the basic variable in terms of free variable, as we discussed in the last example. So this is the end of today's lecture. So feel free and ask questions. Thank you.